All right, so today we're going to talk about something called the order of operations. Any idea what this is? Have you talked about this before in any class before?
Yes.
The order of operations, you've heard that before? Anybody know what it means?
Isn't it when you have adders and factors and then multiply and divide?
Awesome. So this is a specific order to solve problems. Now here's a question. Everybody think about this real quick. What is an expression in math? Now obviously an expression could be like, oh, I'm happy, I'm sad, right? Well, we're not going to talk about being happy and sad in math a whole lot. Because we're always happy because we're doing math, right? Yeah. So what's an expression?
It's like problems with like stuff, adding, subtracting that you have to do first, and then you go, and then you get those numbers, and then you do the rest of the problem, how it is, like adding, subtracting, dividing, multiplying.
So it's a problem.
Yeah.
Yeah. Okay. Would you agree with that? Okay. How about if I said, what's an equation? Is an equation the exact same thing that Nathan just said? I'm asking you. So what if I told you that an expression and an equation in math aren't the same thing? Would you believe me? Grace says no, she doesn't believe me. Grace thinks I'm standing up here lying to her. How many are in Grace's boat? Am I lying to you? They're not. They are the same thing. You're on my side? Good man. Anybody else? So, I'm going to tell you straight up, it's different. So what the heck's the difference between an expression versus an equation? Now I'm going to really confuse you and tell you Nathan's kind of right. They're both problems. But what would be the difference between some problems? What would some problems have that some problems don't have? And we're not talking about operations. What's an operation in math? An operation would be my adding and subtracting and multiplying and dividing. Those are operations. So if expressions and equations are both problems, there's got to be a way to differentiate between the two, right? But what is that? So these are both problems. That I can actually solve or get an answer to. Equations have an equal sign in them. So this one right here, x plus 4 equals 7, that's an equation because it has an equal sign. This one right over here would simply be 3 plus 6. It's a problem that I can solve, it just doesn't say it equals it. That's the only difference between the two. So when we say we're going to solve an equation, we know that there's got to be an equal sign somewhere in the problem. If it says solve the expressions or simplify the expressions, I'm just solving them and finding an answer. That makes sense? Okay. So the order of operations now is the way that I have to do the problem. And we want to have a specific order so everybody does it the exact same way. All right? So we're going to make up an acronym. What's an acronym mean?
I don't know how to explain it, but it's like when words, and then you take the first letter of each one, and that's what.
Perfect. Perfect. We make up some kind of weird word or something, and that weird word, each of its letters means something to us, or to the people, right? What's a famous acronym? Well, like, for instance, you can do it anything, right? We could make a sign that said stop, and stop, the S would mean something, the T, the O, and the P would each mean something. Well, we're going to do that. And the word we're going to kind of make up is PEMDAS. Okay? Ever heard of this? Well, this is going to make sure that all of us are on the same page while we do this. Now, some people like to make this into a saying. Okay? Please excuse my dear Aunt Sally. So if you want to remember that. Okay? It's easier for me just to remember the weird word, PEMDAS. Okay? But each letter is going to tell me the specific order I have to go into for every single problem from here on out when we do a math problem. Okay? This is going to go all the way through calculus. So you're going to use this for a long, long time. So what do you think capital P means? What would you think of mathematically that starts with the P?
Parentheses.
You betcha. So the first thing that we're going to always work with are the parentheses. With respect to parentheses, I'm always going to work inside out. I'm always going to work inside out. So I'm going to go inside the parentheses and see if I can do something. And then I'm going to work my way out. Okay? What are examples of parentheses? Well, obviously, hopefully you know that parentheses could be something like this. Right? We could also have parentheses now that look like this. This has a specific name. Do you know what these are called? Instead of parentheses? These are called brackets. Basically mean the same thing. But a lot of the times, if you see brackets, there's probably going to be another set of regular parentheses on the inside of it. So when we talk about moving from the inside out, especially in this problem right here, I'm going inside my innermost set of parentheses and then working my way out. So there can be multiple sets of them. Okay? Another one that's probably a little bit newer to you would be two groups of vertical bars. Any idea what those are called? If you see two vertical bars around numbers or something, those vertical bars mean what? These are absolute value bars. Ever heard of those? Okay. So this is just probably a newer version of the set of parentheses. All right. So what's E mean?
Exponents.
Exponents. Awesome. So what's an exponent? Give me an example of an exponent. Just a random exponent.
Like 3 cubed.
3 cubed. Everybody agree? Well, now we're in algebra. So instead of having this 3 as a number, we can also have it as a letter, right? X to the 7th. Okay? But what does this mean? No matter if it's a number or a letter, what does this actually mean? What does 3 cubed mean to you? What does it tell you to do?
It's like tying the 3 to multiply to the 3 times.
Perfect. Okay? So, what do I call the bigger part of these exponents? In this case, the 3. In this case, over here, the x. What is the name of that? Do you know? Those two things right there, or the bigger part, is called the base of my exponent. Okay? And then this would be either my exponent or the power. Okay? So, as Alexander said, we're going to say this shows the number of times the base is multiplied to itself. Now, we're probably not going to use our calculators a whole lot, but if you got a calculator, get it out real quick.
I don't have nothing in my life.
That's all right. So, if you have a calculator that looks something like this, for instance, okay? Or maybe you have a really big one that looks like this, right? Or, you know, there's a lot of different versions of it. I think this one's actually. Does everybody know how to put an exponent into your calculator? So if you have this version right here, all right, you would use this little button that says y to the x. All right? Do any of you have that one? If you have this kind of calculator, you're going to use this little key right here that looks like an up arrow. It's called a caret. Okay? So, right up here. So it would look something like y to the x and it's in a box, or a caret. Okay? And that's how you would punch it into your calculator. So bring your calculators tomorrow, and we'll go over and show you those kind of things. All right? If you don't have a calculator, then you got to do a lot of math. You got to get your paper and pencil out and do some math, right? But this is where the calculator is really nice, because if you use those buttons, you can do even something with to the 7th really, really fast. Now, I can't really punch this one into my calculator, right? Because I can't put an X in there, especially the little smaller ones. The bigger ones, you can actually put a variable in there too. Okay? But that's what my E stands for. All right? And then we go on, what do you think M and D stands for? Multiply and divide, right? So these two, though, are kind of linked together. So we have multiply and or divide. But in a sense, they have the same power. Okay? So those are the next things that I'm going to try to do. And because they have the same power, I'm always going to try to work from left to right. That's how I know if I should multiply first or if I should divide first. And then last but not least, we have our A and our S, and that's our what? Addition, and or subtraction. So again, they have the same power. So again, we're going to work left to right. So if there's addition and subtraction in the same problem, always start on the left like you're reading it and go across. Okay. But again now, the reason we use this now is so that everybody's on the same page, and just because Nathan likes to add and Addison likes to multiply better, they have to go in the same order now, because that's what it tells us to do. And then we know then, because we're going in that same order, as long as we do go in that same order and we do everything right, we should get the same answer as everybody else. Now, obviously, we're still going to make some mistakes, but that's okay. So, what do the problems look like? Again now, this is going to say solve the expression, so all of these problems aren't going to have a what? An equal sign. Exactly right. Okay? So, 6 plus 8 times 2. That one's dead. So, where do I start? 8 times 2, right? I have to go over here to the multiplication. And again, yeah, this is going to be really easy, but show your work, even on these easy problems. So, 8 times 2 is?
16.
16. We bring everything else down with it. 6 plus 16? 22. 22. That's it. That's my answer. Piece of cake, right? Realize now, there might be different ways to showing things that you probably aren't as comfortable with as you will be after a while. Meaning, Realize, how many different ways can I show multiplication? What are ways that I can show multiplication? Or how do you know that the problem wants you to multiply? What symbols or what do they use for multiplication?
The x or the multiplication.
An X, right? So, here's the problem though. Now we're in algebra. And algebra is going to throw in some letters, right? So how do I tell the difference between my X as a variable and my X as a multiplication sign? So they're probably not going to use that as much anymore. So what's another one? A dot. Okay, so don't forget, anytime that you see a dot now, we can show multiplication. So we can say 4 times 6. We can say 4 times 6. What else? Another big one to show multiplication is using parentheses. 4 times 6. Anytime that you see parentheses from now on, it means that you are going to multiply. Okay? Now, if I have a letter and a number, I can also just write them next to each other. Now, I probably can't do this as much with two numbers, because if I wrote 4, 6, and I'm thinking in the back of my mind, well, I want that to be 4 times 6, how many of you are going to think that that's 4 times 6? Probably not a whole lot. You're going to say that's 46, not 4 times 6, right? That's a big difference. So I wouldn't write them next to each other like I did if I have a variable. But that would be another way to show multiplication, just writing things next to each other. Okay? How about division? How do I show division?
With the dot, line, dot.
So we go old school, right? 24 divided by 6. Any idea what that little thingamajigger is called? First person that tells me tomorrow what that thing's called gets extra credit. Okay? Alright, I want the name of it. No, start right now. How else can I do division?
You should do like half node and then a line.
We're going real old school, huh? We're going back to grade school. I got no problem with that. What else?
You can put like a number on top and then a line and then.
Basically a what?
Fraction.
Yeah, fraction, right? This is probably where we're going to move to the most now. A fraction. Okay? Sometimes it's at a slant, but it's usually a true fraction. Okay, so again, we can't really change addition, can we? Addition's addition. Okay? Alright? So, carrying on. Next problem. I don't know why I thought of that right away, but where am I starting?
24 divided by 8.
We got to go left to right, right? This one's a great example right here of if I like multiplication or if I go directly in the order that it says, I change the answer, don't I? Because if I go the way it says PEMDAS, it says M is first, I take 8 times 3, which is 24, and 24 divided by 24 is 1. But if I do the problem right, meaning I'm going through PEMDAS, but when I have both of them, I have to go left to right, now what does my answer change to?
3,
Changes to 9. So there's a great example of you got to follow the order of the problem. Okay? Now we look at the ones that get a little bit more complicated. Any questions with those two? Hopefully those two are okay. So now we get a little bit more complicated. 5 parentheses 4 plus 6 parentheses minus 7.7. So everybody try this one on your piece of paper. We'll go through it here in a second, but I want to see where we're at. So again, remember, we're concentrating on our word, PEMDAS. How do we do? Those of you that didn't get 1, do you see what you did wrong? Okay, so again, remember, P, I gotta go inside parentheses. Inside parentheses, even though it's addition, which is one of my last things to do, I gotta go inside parentheses. So I gotta start right here at 4 plus 6. 4 plus 6 is 10. Then I rewrote the whole entire problem, and now I'm gonna go left to right. Because I have multiplication, subtraction, multiplication. So I'm gonna go left. 5 times 10. Then I'm gonna do my other multiplication, and then I'm gonna subtract. Make sense? Alright, let's try it now. 3. Big bracket. Little parentheses, 18 minus 6. Close the parentheses, plus 2 parentheses, 4 parentheses, big bracket. Try her out again. See what you get. Remember the rules. Remember the sets of double parentheses, inside out. Go to the farthest thing on the inside. How do we do? Are we done? Where did you start?
Inside the parentheses.
Okay, where?
Bracket.
Where? What's the first thing we did? Tell me.
18 minus 6.
18 minus 6, exactly right. So, I'm going to rewrite 3 parentheses. What's 18 minus 6? 12. Then I'm going to come over here and do this, because it's inside still. But I'm not going to add, I'm going to do what's 2 parentheses for me?
Multiply.
Multiply. That's 8. And then I'm going to close my bracket. But remember, the brackets are still parentheses, so I got to go back inside there. What's 12 plus 8?
20.
So I'm going to say 3 times 20. And I switched it to parentheses because I still know they're parentheses. I just don't want to write the brackets anymore. And then what's 3 times 20?
60.
60. What do we do? What?
I messed up that second part.
The second part, what'd you do
I
before?
put down the bracket for the 8, so I just thought multiplying 3 times 12. I
Oh,
shouldn't have done that.
you forgot this one.
Yeah.
Gotcha. All right. Make sense though now?
Yeah.
Okay? All right, one more of these kind, and then we'll look at another section. So the last one I want you to concentrate on is something like this. Why I want to show you this one is because it is a little different. To me, I would call these kind of problems right here giant fractions. Right? Because it kind of looks like a fraction, but there's just extra work involved. So when I can think about a giant fraction, this is one of the problems that is special. Okay? We're not going to directly follow the order of operations or our rules of PEMDAS for this. Anytime that you have a giant fraction, I want to simplify. What do I mean by simplify?
Like, do the adding and subtracting.
Yeah, do the problem, right? So I'm going to simplify the top, then I'm going to simplify the bottom, and then the last step is I'm going to divide. And that's why we have to talk about this one, because it is special. Okay? So when I'm going to divide, it is my last step, but it should actually occur before addition and subtraction, but it's not always going to do that in these special cases. Okay? So if I do the top, what do I get? 80. If I do the bottom, 5. Now I'm going to divide, so I get what?
16.
16. Okay? Because otherwise, if I were to try to divide them up and down without doing the addition and subtraction, it gets a little confusing. Okay? Questions with any of that? You just got to go real slow, especially at the beginning, so you don't make silly mistakes, right? Okay? That's why writing down all the steps is going to help. I see some of you trying to do this in your head. That's good and all, but you still got to know how to get there. So the last thing that we want to talk about are verbal phrases. What's verbal mean? Huh? Talking, right? So these are words that are going to describe math. So, what are words that describe addition? Add, right? What else? Sum, because that's the what? The answer, right? Or the total. What else? What words tell you to add? Plus. What else? How about increase? Right? Goes up. All those things would tell you to add. So then we can have words for subtraction. Obviously subtract. What's the answer to subtraction? The difference. What's opposite of plus? Minus. What's the opposite of increase? Decrease. Perfect. And then multiplication and division. Obviously, we could say multiply and divide, but what else tells you to multiply? What words tell you, hey, you got to do multiplication? Times. Exactly right. What's the answer to multiplication?
Product.
The product. Perfect. Sometimes they use this at symbol, right? So you think about shopping. If you're gonna look at, you can get 5 shirts for $4.99 each, right? We would do multiplication. Division, we kind of run out of words for division. They get the short end of the stick. But what's the answer for a division problem? Quotient. And then obviously we could say divide and so on, but they kind of run out of room, okay? So what this means now is I want to try to make a problem, right? The quotient of 18 and 6, what would I write? But what would I write? There you go, 18 divided by 6. The sum of 9 and 5. 9 plus 5. And each of these then would be called a what again? A what?
Expression.
An expression, because why?
Because it has
They don't have an equal sign. Okay, so they're problems still, but they don't have an equal sign. Okay, makes sense? So again, you're going to have to do some of these. Make up or read a sentence and then make up the problem. Okay, we're not to equations yet, so you shouldn't ever have an equal sign in any of these problems. Make sense? Questions in general?
So if you get those problems, do you have to simplify the answer like?
No, today you
Answer
can
the
just
answer?
leave it there.
Okay.
Today you can, that's a great question. Today you can just leave it there. Alright, so here's your problems.
What does he mean?
Like, I mean,
Like for that
like
one?
you see the 18:6, do you have, because that's like the
Right.
question, that's the answer, you have to simplify that.
So he's saying, do I have to put down 3? Or in this one, do I have to put 14? For today, no, that's a great question. You can just leave it like that.